If you're building a multiplayer card game, the moment you go from 1 player to 3 players, a whole new layer of infra shows up. A lobby, reverse proxy, game processes per game, none of that exists in a single player game. So in this video, I'm going to walk through the infrastructure as it runs for my card game. Go on the back end, nginx in front, Godot on the phones, and we'll follow the process of what happens when you hit new game and every hop of the protocol, every leg of the journey. There are 3 pieces of software running in my VM. They are 1. nginx. This is the reverse proxy. It talks to the outside world on port 80, and that's the only thing that the outside world can talk to. 2. The lobby. This is a small Go program, and it kind of manages what games are running right now on which port, and it is able to spawn new playgame services. 3. The playgame service. So this is from the last video, the actual game server. There isn't necessarily one playgame running. There is one playgame running per active game, and each active game can have up to 3 human players. They each are listening on their own private port somewhere in a range that I've designated. And the playgame services are not directly reachable from the internet. That's it. nginx is the front door, lobby is the receptionist, and playgame is the room where the game actually happens. Let's follow the request. I'm on my phone, I tap new game. The Godot client makes one HTTP request. The request has some information. What character am I playing? Which deck am I using? Also, is this a single player game, 2 human game, or 3 human game? The player token in the URL, that's how the client identifies itself. Who am I? The first time that the Godot app launches, it generates a random token and it saves it to local storage. Every request from the Godot client to the server will carry the token. There are no usernames or logins at the moment, just a random string from the client side. Obviously, if you're shipping a real game, you wouldn't want to use a system like that. You would want to tie identity of the client with a particular login, like login with Google, etc. But for a development build with a couple of playtesters, a random token generated on the client side will suffice. And that's it. That's all the client knows how to do at this point. Hey, I want a brand new game. So that request for a new game arrives on nginx at port 80. nginx looks at the URL. It starts with /lobby/ and it matches against a configuration block. Translation, anything that starts with lobby goes off to port 8200 on this machine, which happens to be the lobby service. nginx doesn't do anything clever here. It's just a reverse proxy redirect. The security model is nginx is the front door, and everything else hides behind it. So the request arrives at the lobby. Here's where the real work happens. The lobby does a few things. 1, it picks a port to assign to the new game. There's a configured range, so it picks one that's not in use. 2, it assigns a game ID, basically just a slug. 3, it calls exec to create a new playgame service. That's the moment when the new game comes into existence. It spins up the playgame service and it starts listening on the port that it is assigned. Again, internet doesn't directly hit this service. 4, it writes down all this information into our Postgres database. Say what game, what port, and how many humans are we expecting. 5, it needs to respond back to the Godot client saying, hey, the game has been created and this is the game ID. That response goes back through nginx, back over the internet, back to my Godot client. Now my client knows the game ID. It doesn't know the port. Godot client doesn't need to know what port the playgame service is running on. We'll see how this works out. Now my phone needs to connect to the actual game. What it does is it opens a WebSocket connection to a URL /game/slug of the game /ws for WebSocket. So here's the clever part. The client doesn't actually say which port it's connecting to or which particular process. nginx figures out the rest like this. So 2 things are happening here. First, nginx makes a side request on internal/route game. This is done before routing the WebSocket connection. This side request to the lobby service asks, where does game 1234 live? The which player part is answered by the player token from before, which would have been passed on every single request. And the lobby service looks up, hey, which of the seats is this token / player going to? Either seat 1, 2, or 3. The lobby responds back to nginx with, hey, the game port is this number and this client is connecting in as player 0 in this particular game. Nginx grabs the two headers of the lobby's response and stash them into variables, and then the request is translated to a WebSocket connection to the playgame service using the variables. So it now proxies the WebSocket connection from the outside world through nginx through to the playgame service. Now the URL to the playgame service matters, player equals 0. The playgame service really has 3 seats. You're either player 0, 1, or 2. And the WebSocket alone doesn't tell you which seat you're walking in on. The query string does. So the client never sends it. Nginx figures it out from the sidecar request to the lobby service. While all this is happening, the Godot client point of view is, hey, I'm just connecting to a game. At this point, the WebSocket connection lands at playgame. From the previous video, you kind of know what happens next. There's a Go routine that gets started because there's a new WebSocket connection, and if there's any player input, it passes the message from the WebSocket Go routine to the main Go routine. At this point, the lobby's job is done. It doesn't see WebSocket traffic, it doesn't proxy game messages, it's just the receptionist. Once it introduces you to the right room, it goes back to its desk. If it's a 3 human player game, 2 more players will join in exactly the same way, but with different player indices. That is how you have a multiplayer card game. I think modern software development, it's absolutely miraculous. We're putting together a complete solution with isolated, well-defined pieces that each do its own thing. We have nginx. It's useful not just for protecting your backend services, but it could also be used for terminating SSL. It can serve static files. It's been doing this for 20 years, and I don't have to rewrite that in Golang. We have the lobby. This exists because it needs to know which games are running, and it needs to start up games as new games are created. It doesn't handle WebSocket proxying. We'll let nginx do what it's good at. It's just orchestrating the creation of the playgame services. And then the playgame service itself, or multiple services, as we start up new additional games. Game state is really messy code. I think it's really nice that I could concentrate on the game code inside the scope of one service. And additionally, because each game is its own separate process, any crash on one game will not affect the other games. That's the whole architecture. Nginx in front, lobby tells people where to go, and playgame holds the game. A proper multiplayer game has extra complexities that a single player game doesn't have. My game has nginx, a lobby process, separate game processes, and of course, the Godot client. The front door, the receptionist, and the room. That's what the pieces are. I'm using Golang for the server side, and it's turned out to be excellent for what I'm doing. I'm using Godot for the client side, and it is excellent for what it's doing. That's it for now. Thanks for watching, and I'll see you in the next one.